Thank you very much for attending, and thank you very much for coming to this event. My name's Sam Davies, and I don't work in regulation at all. So me giving a keynote in regulation might beg the question as to why. But I'm an engineer, I'm a software developer, I'm a computer scientist. And one of the core things I found throughout my career is that we need regulation to help us determine what can we build and how do we build it. So I've only got 15 minutes, and I'm going to quickly go through who I am, what FTI are doing in this space so that you get an idea. The practice has grown. We're doing loads and loads of stuff. And then just go through some of the work and challenges that we've seen in this space with some of our investigation work. And then also some of the challenges that I think the technology may bring us in the future for regulation. So that button doesn't work, but no worries. I did have some slides. So my name's Sam Davies. I have spent the last 20-odd years working as an R&D engineer. I began my career as a computer scientist doing machine learning research. One of the first projects that I worked on, I was working for the BBC in the UK in their R&D labs. And we were creating machine watching platforms. So it was AI platforms which could watch and understand audio-visual content in the same way that people could. So we weren't just identifying here is a car. We were looking at the emotive components. There's a branch of computer science called affective computing. In order to do that, we needed training models. We needed to bring in loads and loads of data into our models so that we could train them. BBC is fantastic. It's been broadcasting since about the 1920s, give or take a bit, and they're currently digitizing a huge amount of their content. So we wanted to use loads of that content to try and determine, what's happening in that, how do we feed it into our models, so we can create these kind of generative AI models to allow us to watch what's going on. But we couldn't, because we couldn't figure out what the copyright laws were for something that was broadcast in the 1960s on analog TV, and we wanted to broadcast on a digital domain so that people could feed us the training data that we wanted. So that project, unfortunately, kind of wound up a little bit. And that was sort of the first example of where the lack of clarity over what we can do with the technology has hampered our research. Fast forward a bit, and I was working for a startup. We were doing a lot of machine learning research on analytics for home IoT sensors. We were based up in Cambridge, in a lab there in the UK. And we developed this system, which was deployed in thousands and thousands of homes, a kind of smart thermostat with cameras and things like that attached, all very, very nice. We couldn't use that data, we didn't think, to build our models, because we weren't quite sure what the GDPR regulations were, or whatever they became at that point. So in the end, we had to deploy another system in the US, where it was far more relaxed. And again, that was a huge uplift for us in our innovation team to try and deploy something else, because we weren't quite sure what we should be doing. And I think that this is sort of the crux of where a lot of our issues have come from. We can build technology. Engineers like myself, we sit quietly usually in the corner. This is a relatively terrifying experience for somebody like me who likes sitting behind a computer. We can build that software, and then we want to take that software to market. We want to move across from sort of our R&D papers and our patents through to our pilots, through to our full production systems. And what we don't want is when we're about to deploy it, to get some head scratching from our legal departments or our regulatory compliance departments and say, we're not sure you can do this. And that either puts a pause on all of the work that we're doing, or we have to go and do something else. And we're seeing that today as well. A lot of the talk around regulation comes from looking at sort of digital assets, which in cryptocurrencies, which makes a huge amount of sense. I've been working in blockchain and digital assets for, blimey, about 8 years now. Goodness me. Which sort of vaguely makes me a seasoned veteran, which is a bit daft because that's not that long. I don't really have many digital assets or cryptocurrencies. That doesn't hugely interest me. I think it's fantastic the way we can transfer value in these ways. The core interest for me are on the underlying blockchain platforms themselves, how we use smart contracts in an autonomous manner to enact business transactions between parties, to execute business logic, to create new enterprises. My background's in machine learning. Machine learning is systems, and AI systems which can think and do things for themselves. We've now got this fully decentralized and autonomous platform which we can deploy these things onto. There's a huge amount of talk about how can we regulate AI? How can we regulate the research that those folks are doing so that we don't end up in some kind of robo-apocalypse, which I think is absolutely right. But These things will deploy on blockchains. These things will have these autonomous platforms on which to deploy. We've already got DAOs, decentralized autonomous organizations. If anyone remembers, one of the first, I think probably the first and the biggest issue, shall we say, with blockchain was the DAO, the huge hack on one of the first Ethereum kind of VC DAOs. For those who may not remember, it was 2017, 2018, give or take a bit. A DAO was set up to enable people to basically put funds into this contract, smart contract running on the Ethereum blockchain, and then you could vote as to which projects were funded from that, kind of like a VC. Had about $150 million worth of ETH in it, which at the time represented about 15% of the total supply. Somebody sat down and worked out how they could use the DAO's code, use the smart contract to extract the ETH from it. They didn't do anything illegal. Possibly, maybe, not sure. They didn't do anything wrong, possibly, maybe, not sure. They used the code that was out there. At the time, myself and lots of others, we were proudly stomping around saying code is law, the smart contract is law, whatever the smart contract says, you can do. Somebody used a smart contract, take loads of money out. That resulted in the Ethereum blockchain splitting in two. The fork, if people remember it. We originally were going to have a soft fork where we'd just unwrite the transaction which happened, which is interesting because we call these immutable ledgers. And eventually, a bug was found in the soft fork. So we went for a hard fork. We split into Ethereum and Ethereum Classic. How do we regulate? How do we account for that? That is a huge area that I think is really interesting. Another really interesting, oh, cool, I've got slides now. Sorry, this is FTI. We do lots of interesting work in blockchain and digital assets, primarily around investigations in cryptocurrencies. So we use lots and lots of different tools, and we create our own tools, the bit I do, as we need to help us identify what has happened in investigation and litigation. We also have, where's the bit that I've been doing a lot of work on? Sort of a blockchain as a service platform, which is an Ethereum-based platform that we've created to allow enterprises to very easily deploy blockchain applications. One of the issues that sort of found many, many times throughout my blockchain career is that it takes an awfully long time and can be very, very expensive to deploy a blockchain application if you get some developers and some consultants come in and identify what you need to be doing. Whereas we can create, I hear this, blockchain as a service to help us push through that and to help with the ease of deployment. We've done many investigations and many engagements with clients, and we've got Steve McNew, who is our practice lead, and we'll be here later tonight. He's an expert testimonier, so he goes and he will present in court the findings that we've got and be that expert on blockchain and digital assets, be it from the sort of high-level regulatory aspect right down to the low-level code. So these are sort of some of the areas that we work in. There we go. And these are some of the interesting things that have gone wrong. And this kind of leads me back to what I was talking about. Tornado Cash, I think, is a very interesting and very cool one. Tornado Cash is a mixer. You put funds in, it mixes them out, funds go out, you lose that link as to where stuff's gone. A lot of the work we do in investigations is just following the bouncing ball, basically. You know where one transaction's gone, and you can follow it to another one. Particularly easy if you're looking at some of the blockchains which use something called UTXO, unspent transaction, so you can find out exactly where the tokens have gone. It's very, very good. Tornado Cash broke that link. And Tornado Cash, the developers created it as open source. They created the code. They put it in the GitHub repo. They deployed it. And they burnt their private keys. They burnt the method they had to actually control this. So it was, they had no control of it. It was decentralized in the fullest extent, I would argue. There were lots of arguments made that it could facilitate money laundering. So it was shut down. And the US government went after the developers. They shut the GitHub repo down, which was interesting. GitHub is a place where developers, we store all of our code. It's owned by Microsoft. And they shut that down, which was really interesting. And a very interesting development. And at the same time, everyone was saying, you know, is this illegal? Should it be shut down? Isn't it just software? Surely it's the usage of the software. The devs haven't done anything wrong. They just created it. But is that their fault? At the same time, the firm I was working for at the time, we were developing something similar. We were developing a zero-knowledge technology, which enabled you to transfer tokens from one person to another on an EVM blockchain. with no one knowing anything about the transfer except for the sender and the recipient. So blockchains, usually when you transfer, you do the transfer to one person. Everyone on the network effectively, or take a bit, validates that transaction, make sure it's happened, check your balance, checks their balance, checks the keys and permissions, does the transfer. Zero-knowledge tokens, zero-knowledge proofs allow you to do that, but with only 2 people knowing. So we'd spent a fearsomely long time developing out this technology, and it was going to be really good. We were discussing earlier with some folks that I'm a big believer in sort of public blockchains. I like this utility blockchain. Problem we have with public utility blockchains is everyone can see what you're doing, be it from token transfers or smart contract executions. And so the zero-knowledge technology that we were developing would enable us to use public blockchains, but with privacy. However, because it worked in a similar way to Tornado Cash, and because we weren't quite sure if we could do this, I mean, would the US government come after us? Would they shut our repo down? I was working for a Big Four audit firm at the time, and they are very, very nervous about anything that could be a little bit dodgy. So we sort of stopped that research. And I think that for me was kind of a shame. We could build this stuff. This stuff was going to be useful in so many different domains, but we weren't quite sure what would happen when we were deploying it. And so these are some of the, in the last minute I've got left, these are some of the areas which I think are coming along, which we really need to have a look at. So zero-knowledge proofs and this kind of sophisticated obfuscation of what is happening, the fact we can use these public networks, and we've now got the cryptographic techniques to transfer stuff around. NFTs is a good one. I mean, it is now a thing, really, isn't it? It's not just sort of people buying a monkey in a hat picture, but we're using them for so many different, loyalty points, for example, are moving into this at a great rate of knots. And do we need to, can we build that? If we build a system which enables me to collect loyalty points from one organization, can I trade them for loyalty points for a discount with another organization? Does that count as money in some ways? Does it need to be regulated? Digital twins and identities, oh, I love these. Decentralized identities are fantastic. If you haven't, go and have a look at them. But if I create a blockchain identity for myself, and I tie it into my biometrics, does that count for anything? Does it not? It's like the idea we used to have. We used to do lots of work with the digital twins. We'd create a blockchain representation of a physical asset and say, this is now the digital version of that asset. Is it? Was it really? If we've got the talks tomorrow on sort of tokenization of real estate, is it actually kind of the legal owner there? Misrepresentations, blockchain technology can be quite complex. Folks, good engineers, we try and make it so that it's not complex, but you can misrepresent what's going on. You can wrap it up in long words and say things, use long engineering words. And then my favorite topic is decentralized computing and AI. We've got autonomous systems. We've now got fully autonomous platforms these autonomous systems can run on. What are we going to be doing around there? So in brief conclusion, there's a lot more, I think, than just looking for sort of tokenization or sort of digital assets. There's a whole host of technology. And from an engineer's aspect, if we can work together to try and identify what regulations are so that we can build the right stuff in the right way, that would be really useful. And thank you very much for listening. That's my time. Thank you.